Lesson 8, Exercise 7H, Interpreting the slope and intercept of a regression line. This will be the last lesson that is dedicated to exercise, or chapter 7 rather. The learning goal for this exercise is what information the intercept and a slope holds for regression lines. The success criteria is to be able to determine the intercept and slope of a regression line and interpret their meaning based on the context provided. Whatever method is used to determine the equation of a straight line, the intercept and slope of the line can be interpreted in terms of the variables within the question. This interpretation gives us further insights into the relationship between the variables. Interpreting the slope and intercept of a regression line. For the regression line in the form of y equals a plus bx, the slope, which is the b, or the number that will be in front of the x, this predicts the change in the response variable for each 1 unit increase or decrease in the explanatory variable, or in this case, x. The intercept a, which is here, predicts the value of the response variable when the explanatory variable x is equal to 0. To get a better understanding of this, we're going to look at the context of this question here. A regression line is used to model the association between the time 10 students spent studying for an examination and their mark. The equation of the regression line is as follows. The mark is equal to 30.8 plus 1.62 times the time. We can now see in this instance that no data has been provided to us. We don't need any data. The data has been used to create this equation here, and this equation can help us predict what the mark a student will get depending on how much time they spent studying. So in this case here, the time is our explanatory variable, or our EV, and the mark is our response variable, or our RV. But we're not making predictions now. We're not going to provide a time and then have it spit out a mark. In this case, we're going to write down the value of the intercept, and we're going to interpret this intercept in the context of the variables, or in other words, in the context of the mark and the time spent studying. So for the first question, AI, write down the value of the intercept. In this case, the intercept is just this value here, which is A, 30.8. This is our intercept. This part is simple, finding the intercept, because we're just extracting information that has already been provided to us. But where it gets tricky is having to interpret what this intercept means based on this context. All this is saying is that it is assumed, or it is predicted, that if a student spent no time studying, no time, zero, absolutely nothing, they spent no time studying for a certain exam, then they would at least achieve 30.8% for their mark. And this is purely based on the data that these 10 students provided. If more students provided information and gave us more marks, this regression line that relies on that data will then change accordingly. So maybe they'll have a lower or higher mark. It really depends. We don't know what this data is, but we do know that if a student spends no time studying, it is predicted, remember this is just a prediction, it is predicted that their mark will be 30.8. Now, I did say just before it was 30.8%, but I actually looked back at the question and it doesn't have that context. It doesn't say that it is given as a percentage. So I'm not going to write percent, I'm actually just going to leave it as whatever the variable is, so 30.8. If it said points or percentage of some sort, then you would put that context in, and in this case, it's just left as 30.8. And that's all there is to it. Why this is tricky though, is because it's hard to determine what variable you have to relate the 30.8 to. And it purely depends on what the EV is and what the RV is. So in this case, because we are talking about the intercept, it is the time frame that will always be 0, or the X frame will always be 0 in this case, to then elaborate what essentially the beginning mark will be. We're now going to interpret the slope. So right now we're going to write down the value of the slope, and then we're going to interpret that information based on the slope in the context of the variables. So in this case here, our slope is 1.62. And this is determined by the number that's being multiplied by the explanatory variable, or the b value in this case. So again, this part is simple, but to get our next part, interpret the slope in the context of these variables. What this slope is saying is that for every whole unit, in this case for every time frame, and the time, let's look at the context, is the time given in minutes or hours? The time is given in 10 minutes starting for the examination and their mark. It actually does not say what it is. So we're going to just use it as time frame. It could be hours, it could be minutes, but I'm not too sure because it doesn't say what the specific time frame is. So in this case, when we interpret the slope in the context of their variables, it is predicted that for each time frame that a student spends studying, they will be adding 1.62 to their mark. 1.62 marks to their actual overall mark. So you would say that for every, now I'm using the word time frame, for every time frame, and I'll put this in quotation marks. So for every time frame that is spent for a student studying, let's scroll this down a bit, they will add 1.62 marks to their overall score. And that makes sense in the sense that, let's imagine they spent from this regression line that we have here, this equation, if they spent 1 hour studying, it's predicted that they'll add another 1.62 to their initial, which is 30.8. Because remember, when the time amount was 0, they were just going to score a 30.8 based on the information that was given to these 10 students. Now, it seems kind of unrealistic. You would think, oh, if I spend no time studying, I'll probably get a mark of 0. Well, sometimes you can spend no time studying and actually get a relatively higher amount in comparison to the number 0. And this is just provided by the 10 students. But then for every time frame that they spend, they'll add another 1.62. So if I spend, say, 10 hours studying, I will be adding 16.2 units to 30.8, and that will give me a prediction of what my mark will be. Obviously, the more time I spend, the higher the mark will be, but this now gives this dissects it and gives us a little bit more information. Okay, now at the end of the day, you got to remember that these are all predictions. Okay, these are all predictions. You cannot make an affirmative answer or provide an affirmative answer to say this is exactly what you're going to get based on this is how long you're going to spend studying. You can't, because it's just a prediction. We can only predict what the future is, and the only way we can make a prediction is by relying on the data that the students provided to us and then creating an equation through some fancy mathematics behind it, create an equation to help us make the best prediction from it. Now, a lot of mathematicians and statisticians alike use these regression lines to make predictions that go far beyond the concept of just how long you spend taking on studying versus your mark. These predictions can include determining weather patterns. It also gets into hacking security, the likelihood of hackers attacking a certain security database. These predictions can be made. Banking gets into so many fields. But right now, all you need to know is how to interpret the intercept and the slope based on the context that has been provided to us. The questions that you need to do for this exercise is exercise 7H, interpreting the slope and intercept of a regression line, which is 1, 2, 3, and 4. You'll also notice that 7I, the statistical investigation, which is question 1 and 2, this right here is just a summary of everything that has been looked into from 7A to 7H. So there won't be a lesson video for 7I. And then afterwards is the chapter review. This concludes the chapter 7, investigating relationships between two numerical variables. See you potentially in the next video.